In this tutorial, you will learn about the modern learning dilemma, technology-enhanced learning, and techniques for learning. Something modern people take for granted is that in all of human history, learning has never been easier. Never before has education been so widely available, and, more specifically, because of technology allowing information to be more accessible. Today, you can access any information that has been published from the comfort of your own home, on the train, or from the middle of a field. Anywhere you have access to the internet, whether from your home broadband connection, public Wi-Fi, or mobile phone data plan, you can access the information you need to learn in the form of text, video, and audio. But at the same time, people have never found it so difficult to learn. At face value, this statement sounds like a contradiction to learning has never been easier than ever, but the same technology that makes learning easier also creates many distractions that never previously existed. So, while people have the ability to use technology like the internet for learning new knowledge and skills, most people are easily distracted by the ability to use these technologies for alternative purposes. That is, instead of committing to using video and social media websites for learning, people will be distracted by entertainment content and communications that have nothing to do with their learning. What starts as minutes of distraction can easily become hours of distraction. The key to benefiting from using technology in your learning is not just about your ability to use technology, but also the discipline you have in using technology in the right way. Learning anything can be performed in 3 stages. The first stage being awareness. Developing an awareness is about understanding the purpose for what you are learning. People often take this for granted to the point that they forget to recognize the reasons for the skills and knowledge. This prevents them from being able to understand explanations that seem obvious to anyone with this awareness. Let's use football as an example. We take for granted that football is a game where a team must put the ball into the other team's net in order to win. This basic awareness about football is what allows us to understand the game in ways that somebody without this awareness would not be able to. For example, somebody without this awareness of football would see a game as being about people running around the field to kick a ball at a person who stands in front of a net. Their lack of awareness would prevent them from understanding how this person is guarding the net from the people who are trying to score a goal. In this case, awareness about football is not about how to play the game. It's about setting the perspective you need to make sense of the explanations and exercises you will be engaging to learn the knowledge and skills. The second stage of learning is practice. In the case of football, this is not about learning to play a game, but specifically the individual skills to use in a game. Practice is engaged as specific exercises that are designed to build knowledge and ability that will be used during a specific part of a game. Exercises include how to control the ball, how to pass the ball to another player, and how to score penalties. All of these exercises are about the skills needed for a specific part of a game, and not about playing the whole game. Similarly, practice for learning maths is not about learning to do a full exam or solving a full problem. Practice is about learning the individual skills that can be applied to future problems. For example, you start by learning how numbers are represented and how to add them together. You only progress to solving problems after you have focused on learning to do simple addition. The final stage of learning is the application of the skills you have learned. In football, this would be about playing a game for real, using the skills you have practiced. There are many levels to application where each has to be practiced for. In football, you start with a friendly game in the team you train with, and then you may progress to other more advanced levels, such as amateur competition, professional, and eventually for the national team. The same concept applies to learning maths after practicing the individual concepts. Application can be in the context of solving theoretical problems, applying maths to real situations, and also for exams. Each of these is a different type of application that requires a specific type of practice. For example, scoring high marks in an exam requires practice for exam questions, which is a different type of practice for applying maths to real situations such as creating a spreadsheet or computer game. The knowledge you gain from learning can be organized into 3 categories. The most important is the concept. A concept is an idea about something. For example, in maths, the concept of being able to count part of a whole amount. The concept includes how to do the counting and how to describe the amount in writing. But understanding a concept and being able to communicate it can be problematic. Any concept you learn can be supported by language, where special words are used to describe important parts of the idea. In maths, the ability to count part of a whole amount could be described as a fraction. The word fraction tells people how you intend to write the amount you are describing, with extra words also available to describe the counted amount and the total amount. By learning the language used to describe the idea, you gain more ability to understand how other people describe the concept, allowing you to make sense of a wider range of learning materials and to understand instructions given in future application. Although learning the language associated with a concept isn't critical for building your understanding, not learning the words associated with ideas could prevent you from being able to apply your knowledge. For example, where an exam uses specific words to describe a question, you may have the knowledge to provide the full answer, but not be able to make sense of the question, resulting in you providing the wrong answer. The final tier of knowledge for your learning is how to make use of the idea. This type of knowledge is about recognizing the patterns for where the idea can be useful, along with techniques to apply the knowledge successfully. For exams, you may learn how to recognize the types of questions that require the use of specific techniques you've learned about. Additionally, you may have learned methods to perform the techniques you use to generate answers faster. Learning this knowledge allows you to gain the full marks for questions in less time, meaning you have time to gain more marks in the exam by answering other questions and checking your answers. New knowledge often appears to be complicated at first glance. However, complexity never exists by itself. Anything that is complicated is made from smaller parts that are more simple and easier to understand. This means that any concept or idea you need to learn can be broken down into simpler parts. You can repeat this process until you reach a point where you are learning how a series of easy concepts are linked together. In this example, a difficult concept can be broken down into medium concepts, and these medium concepts can be broken down into easy concepts. You can learn the difficult concept from any of these perspectives, as long as you recognize how to link the simpler concepts together. Your understanding of a concept can be made from 2 parts: facts and processes. Both have their advantages and disadvantages. Facts can be recalled and applied quickly and accurately if you've learned them properly. However, each fact is limited to a specific part of the concept. This means you have to memorize many facts about the concept which takes a long time to learn. In maths, you can learn about multiplication as a set of facts called the times table. This is a list of all the answers for multiplications up to 12 times 12. Learning the times table means that you can quickly and easily provide answers about multiplications up to 12 times 12 without making mistakes. However, it takes a lot of time and effort to memorize all 144 of the answers, and still, the knowledge of the times table doesn't provide answers for multiplications beyond 12 times 12. On the other hand, processes are about learning the steps to perform the concept. A process can be used to identify every answer the concept is used for. This way of understanding is fast and easy to learn, but slow and difficult to apply. For example, it takes just a few minutes to learn that multiplication is the process of repeating the addition of the same number. However, the difficulty of using processes is in the application. Solving multiplications as a set of additions requires plenty of practice to get the right answers without mistakes. And even with this practice, finding the answers will always be slow. It will never be absolutely clear if a mistake has been made. Fortunately, you don't need to learn exclusively with facts or processes. You can combine them to form a strategy that provides the benefits of both. Let's use 7 times 20 as an example. This is difficult to solve when relying entirely on facts or processes. We don't know the answer to this multiplication as a fact if we've only learned the times table up to 12 times 12. And while we can add 7 together 20 times, it is very possible that a mistake could be made that goes unnoticed, such as losing count of how many additions have been made or performing one of the additions incorrectly. A strategy to solve this problem could be to break the multiplication into smaller parts that can be answered by the times table and then add these parts together. In this case, the calculation could be split into 2 groups where the 7 is multiplied by 10. This is because the 2 10s add up to 20. A fact from the times table is that 7 times 10 is 70. This is the same answer for both parts that the original multiplication was split into, meaning that the final answer is 70 plus 70, which gives 140. There are different methods you can use for learning, meaning that you can pick and choose your approach to fit your preferences and requirements of the situation. Observation is a way of learning by watching. This approach to learning is entirely based on being able to see the concepts in action. Observation-based learning can be delivered as a demonstration, talk, or through real-life experiences, in which you can observe using video or real-life attendance. A big advantage of using video and audio recordings is the ability to repeat parts of the demonstration or explanation at your own pace. Investigation extends observation for you to choose the different perspectives that you can make a conclusion from. To do this accurately and effectively, you need the ability to select the most relevant perspectives to investigate. To identify a relevant and accurate conclusion, you also need the ability to recognize consistencies in the information you collect. While investigation provides you with a lot of flexibility to research the parts of a topic that are relevant to your ambitions, you must be aware of choosing the most appropriate techniques to gather your information. This includes questions to ask, information sources you read from, and your approach to performing experiments. Feedback is a way of learning from opportunities you create to receive a response. The most obvious form of feedback is from other people, where you receive a response based on their knowledge, opinions, and perspectives. Less obvious forms of feedback include the use of technology, such as using a calculator to confirm whether a calculation technique is correct, or a computer system to see the results created by a set of code. You can engage feedback for different purposes, not just to identify whether you are right, but also to identify whether your knowledge can be extended. Feedback can be gained through discussion, the questions you ask, demonstrations of your work, and experiments you perform. And finally, reinforcement is about strengthening the knowledge you have. This includes everything from improving your ability to recall your knowledge to understanding how the knowledge you've learned is associated with other information and concepts. Reinforcement allows you to improve the application of your knowledge through better awareness, whether that's being consciously aware of your knowledge or better ability to recognize where your knowledge is relevant. Reinforcement can be achieved through exercises that include writing details of your knowledge, drawing diagrams, demonstration, and engagement of projects that use the knowledge and skills you've learned. Even thinking about the knowledge is a way of increasing your consciousness that leads to realizations and ideas for future practice. In summary, technology makes learning easier than ever before. Using technology requires you to have more discipline. Split your learning into awareness, practice, and application. Complicated concepts can be broken down into easy concepts. And learn efficient strategies that combine facts and processes.